Welcome back to our channel. Please give feedback to us for more number of electrical videos. Let's derive torque equation of a DC motor. Motor which converts electrical to mechanical, right? Supply we are giving electrical, it gives mechanical output in the shaft in terms of rotation. We were wondering, but it's not a magic. We'll see how exactly rotor rotates and how exactly torque is developed, on what factor do they depends. Watch the video till end. These are the parts of a DC motor. If suppose one part is missed, definitely motor will not work, shaft will not rotate, torque will not develop. So all the parts are very important for motor, even for your body, right? Let's derive torque equation of a DC motor in detail. Torque is nothing but twisting force or turning force or circumferential force about the axis, right? Or torque is nothing but force into radius of the pulley, right? I just extended the shaft into here. I just connected one pulley or a drum, okay? This is your drum. You can find in your laboratory, right? These are the weights and then this is a belt. I'll just replace this drum into here. So there is a shaft and having this drum radius R and F is the force and speed in RPM, right? Best example to understanding the torque is your water bottle cap opening. We need a force, right, to open the bottle. So that is called as a twisting force, called as torque. I will draw internal circuit diagram of this diagram. So there is a field winding, okay, and there is an armature, and there is a supply voltage here, terminal voltage. So inside the armature we have a armature conductor and EB, right? This is EB and this is RA. So this one is IL and ISH. Whatever the current flowing here is IA, armature current. We'll start derivation. Just to assume this pulley or drum is rotating. Okay. Consider pulley radius R meter and force Newton and speed in RPM N. What is the definition of torque? Torque is nothing but force into radius, right? Unit is Newton meter. Equation number 1. What about work done? Work done is equal to force into displacement or distance traveled or circumference of this circle. I mean drum, right? So distance traveled, right? So F into what is the circumference of this drum? 2 pi R, right? So work done is equal to F into R into 2 pi. Watt second is a unit of work done. So W is equal to F into R is what? See here, torque. Torque into 2 pi. Right. So equation number 2. What about mechanical power developed by the motor? I'll just draw a diagram here. So there is a mechanical output from the shaft. So this is a load, okay? This is mechanical output from the shaft. Just it is connected over here. Here there is a EB present, okay? EB will be there, right? So what about mechanical power developed by the motor? So PM is equal to work done by unit time, right? Just I considered one revolution, okay? One revolution. Number of cycles per second is equal to N by 60. Time taken for one revolution, that is 60 by N. Have you got this one? Omega is equal to 2 pi F, where F is equal to number of cycles per second, that is 2 pi N by 60, right? So T is equal to 60 by N, right? So P mechanical power developed is equal to work done is T into 2 pi, okay? And what about this one? Time taken 60 by N, right? So mechanical power developed is equal to, just it goes to numerator, T into 2 pi N by 60, right? What about 2 pi N by 60? 2 pi N by 60 is omega. So mechanical power developed by the motor is T into omega, right? So this one is shaft torque into omega. Equation number 3 you can write, okay? So we got PM is equal to T into omega. Twisting force into omega, angular velocity, right? Next, we'll see electrical power output of the motor. How exactly power will be flowing from supply to the load. Without electrical power, there is no mechanical output, right? So, I'll be applying KVL for this loop. So, V terminal voltage minus IARA, see here, minus IARA minus EB is equal to 0. So, VT is equal to EB plus IARA. Just I'll multiply armature current for this equation. Okay, multiply armature current. You will get Vt into Ia is equal to Eb into Ia plus Ia square Ra. Right? I'll rewrite once again. Vt into Ia. Just I multiplied Ia because we want power equations, right? So Eb into Ia plus Ia square Ra. By seeing this equation, we can say this one is input power, power input, because DC power is equal to VI. This is input power, and this one is what? Output power, right? Output power, and this one is what? Losses. Next, I'll equate electrical output power to the mechanical output power, because both are equal, right? This electrical power here there is a shaft will be there. Slight difference you will get, but both are equal, right? So, electrical output power P is equal to EB into IA. Without electrical output power, there is no mechanical output power, right? PM is equal to PE. So, PM is what? T into omega. Equation is there. Is equal to P is what? EB into IA. EB into Ia. So T into omega is what? 2 pi n by 60. So Eb is what? 5 p n z by 60 A, right? That is back EMF into Ia. So 60 cancel, n get cancel. Only you will get torque is equal to 5 p z Ia by 2 pi into A, right? So this is the torque equation of DC motor, right? So finally, shaft torque or torque is equal to TST, okay? So 5PZIA by 2 pi into A Newton meter. So finally TST shaft torque, okay? So 0.159 5PZIA by A Newton meter. This is the torque equation of DC motor. Okay. From this torque equation, torque is directly proportional to Ia and torque is directly proportional to phi. Okay. Once again, we will revise derivation of torque. Consider a pulley or drum having radius of R meter and force is F and then speed in RPM. This one rotates in this direction. So torque is nothing but force into radius and work done is force into distance. Finally, we will get T into omega. T is equal to torque and omega is equal to 2 pi n by 60. Right. So after that, electrical output power is equal to mechanical output power. So EBA is equal to T into 2 pi n by 60. So finally, we got so equating these two equation. Finally, torque is equal to 0.159 phi Ia Pz by Newton meter. Final touch within 1 minute. Torque derivation. Consider pulley having radius of R meter and force F. N is the speed in RPM. Right. So torque is nothing but force into radius. Equation number 1. And work done is equal to force into distance traveled. Here 2 pi R and mechanical power developed by the motor is work done by time. Time is 60 by n. Keep it in your mind. So you will get F into R is what? So F into R 2 pi 60 by n. Finally you will get F into R is T, torque, right? So into 2 pi n by 60, right? So finally we got T into omega. See, just I'll tell you how I should remember. Here there is a rotor armature conductor. Here EB will be there, right? So Here there is a shaft connected and this is a mechanical output. Here one mechanical output, here one electrical output. These two are equal, then only we can find torque, right? So T into omega we got. What about electrical power developed by the motor? Just you apply KVL, this is VT, this is IA current, okay? So VT minus IA RA minus EB is equal to 0. VT is equal to EB plus IARA. So just you multiply current for the throughout the equation VT into IA into EB into IA plus IA square RA, right? So this is power input, power output, losses. Input is equal to output plus losses. Just this one EBIA. So this one is PM, mechanical power developed. So PM is equal to PE. So PM is T into omega is equal to EB into IA. So T into 2 pi N by 60. EB is equal to what? 5 P N Z by 60 A into IA. So N 60 60 N cancel. Finally get T is equal to 5PZIA by 2 pi into A, right? Newton meter. Our torque is equal to 0.159 5PZIA by A. This is your torque equation.